Assalamu alaikum warahmatullahi wabarakatuh. This is Mohammed Alzahrani. I'm doing here a small project, part of the sensor and actuator subject for Dr. Jabir Al-Yamani. Hope you enjoy watching with me along all this video. Actually, it is interface the Raspberry Pi with DHT11, the digital temperature sensors. This DHT11, it's actually some of the features. It's low cost and it read from 3 to 5 volts. It needs 2.5 milliampere as a current. It is good for humidity, to detect the humidity from 20 to 80%. With 5% accuracy, and it is also read from 0 to 50 degree temperature with minus or plus 2% accuracy, digital output, and also the library can be easy downloaded from the internet for this sensor. The components I have used for this sensor, it is Raspberry Pi and DHT11 sensor, test board, and some jumper wires. While I didn't use it because I already connected directly to the Raspberry Pi. Here, one of the important and most important things is the data sheet for the sensor. You need to download and read carefully the data sheet for each sensor, because there is some aspects you should consider during the programming for the sensors, and some technical information you need to know about it when you deal with this sensor. Actually, this sensor have 4 pin. Pin number 3 is not usable. We use pin number 1 for VDD 3 to 5 volts, and pin number 2 for signal and data, and number 4 for the ground. Here, as I have mentioned, the sensor already connected directly to the Raspberry Pi. So pin number 1 is connected to the 3.3 volts, pin number 1 and Raspberry Pi, and pin number 2 is connected to number 7, which is for data, and pin number 4 is connected to pin number 9 and Raspberry Pi. So this is GPIO for Raspberry Pi. You should know about it to be able to connect the pin in right manner. And actually, here the code I have wrote it in Raspberry Pi to download the library and install it from the internet, and the code to compile and install the Raspberry for DHT LT11. And actually, after you install the library, you just need to write a small code, which I wrote it there. It is to import the library, which already we have installed it from the internet, and determine the bin for the data, which already it's number 4, and write the command to tell the Raspberry Pi to read the temperature and humidity of the sensors, and command to show up this result, which will be like this. Here we go. This is the interface of Raspberry Pi with my laptop, and already I have wrote the program in Python, and this is shortcut for it to save the time. We just run the program. Here, as you see the program, simple code, just import the library of DHT11, which we downloaded earlier, and here we determine the DHT pin, which is number 4, to get the data, and the command is just from the library will ask the sensor to read temperature and humidity, and command print to show up the result and data, which is we get it from the sensor over here. We just run the program. Here we go. Start the sensor, sending data to through the Raspberry Pi to the PC, and it show up here as you see. That's all, and we stop the program from here. Here we go. As we have mentioned, the sensor is already connected to the Raspberry Pi, and Raspberry Pi is already connected to the computer through the Ethernet cable, and this is for the source of the Raspberry Pi from the USB. And here, as we mentioned, that already pin number 1 or plus is connected to the number 1 and Raspberry Pi, and pin number 2 is connected to number 7, which is for data, and number 4, the gray one, to number 9 and Raspberry Pi, which is for ground. And here is the second part of our project, the experiment, which is connecting sensor, the analog sensor LM35, to the Arduino. This is some of the features of the sensor LM35, which is calibrated directly in Celsius centigrade. Does not need any external calibration. Read temperature from -55 centigrade to 150. Operate from 4 to 30 volts. Low cost and low self-heating. The components we needed for this sensor is Arduino. I have Arduino Mega. It doesn't matter. You can use Ono. We have LM35 sensors and test board and some jumper wire. As we mentioned before, that the data sheet is very important to know the specification of the sensor you're dealing with. So you consider some of these aspects in program. And actually this sensor has 3 pin. Pin number 1 is for the 3.3 volts. You connect it to number 1, and pin number 2 is for the data. You connect it to analog output A1, and number 3 is for ground. And as you see here, it is connected 3 to the ground, number 3 to the ground, and 1 to 3.3 volts in Arduino, and this is for data which is connected to A1. And we write the code. We start identifying the sensor, which is LM35 or 35, and bin for data, which is pin number 1, A1, analog. It's output analog. And we write our code to serial begin, which is we'll read the data through the serial port in the computer to see the output. And here we write the code to read analog output read from pin number 1, which we identified here, and temperature, read temperature, and also serial print to show up or get the temperature, and also to see show up the result from the serial port, and you will see it as a temperature and centigrade next to the reading, and print this result and delay for data to show up this result every 1 second, and it will show up like this through the serial ports. Here is the Arduino Mega. We connect the 3.3 volt to the sensor, and ground also, and data through the green wires to A1 in Arduino, and we start it. Thank you for watching, and wish to see you again in different video. Thank you so much. This is Arduino. We identified a sensor LM35, the analog sensor, and because of it is analog, we determine the lead for output, which is analog pin number 1, and we write the command serial begin to communicate with the computer through the serial port and show up the results. And we do the loop, our program, which is read the data from the sensor LM35 analog read pin number, which we identified here, and float the voltage is convert the voltage signal, the signal converted from the voltage to a data through this formula, and we write the command serial print the temperature, and write C, which is next to the temperature which show up there, and our reading it will right next to it is C, which is centigrade, and delay is read every each second or every each. Here our sensor reading start reading the temperature as we determine it there, and centigrade to write next to the reading centigrade. Before we do actually start the program, we should make sure that we are choosing our Arduino. Either it's Uno, I'm using Mega because I have Mega, so it's been chosen as a Mega Arduino, and configure also the board. This is the most important before you start. And when you load the program, you will start it from here. If there is any wrong with your program, it will get a message here that this program has a problem and you should solve it. And this is the all about our sensor LM35. I hope you enjoy watching. Thank you for. Here is the Arduino Mega. We connect the 3.3 volt to the sensor, and ground also, and data through the green wires to A1 in Arduino, and we start it.